show of hands, English, Spanish, because we can do it in either or. So English, Spanish. Do you have a translation, though? Okay, if you want to, yes. And then we start. Okay, so let's go with. Do you understand English? Everybody? Yeah, let's do English. Don't worry, don't worry. Hey, mate. Yeah, for sure. Okay. Hello, everyone. I'm Federico Pinho. Shall we start? Amazing. Hello, everyone. I'm Federico Pinho, Head of Products and Operations at CoinFabrik Research. We are CoinFabrik's research division. Today, we're going to be speaking about how to build better security tools, a little bit about SiteScout. SiteScout is the umbrella tool for different open source security tooling we've been building for different ecosystems. So for the demo, if you want to go ahead, you have it on the session panel as well, but you can go here, you will find a script that you can go ahead and run it in your computer, so save it for later. This is going to take you to the first CodeQL implementation for any blockchain language, now in Solidity for the first time. So a little bit about the team, what we've been doing. We built the first static analyzer for Clarity, for Ink, and for Soroban, which are Stellar, Polkadot, and Stacks. We built the fuzzer for the Stacks compiler that actually had interesting findings. We have a joint research collaboration with the computer science department of the University of Buenos Aires. And we just built and are launching today here at the event the first open source implementation of CodeQL for any blockchain language in Solidity now. So how do we build better security tools? I would argue that with the process. And for you developers, I hope you can follow with me for a while. We're going to see code in just a little bit. But the process, you're going to find it if you go with product. It's going to be called design thinking. It can be called the scientific method. But it usually goes around these 4 parts: research, define, build, test, learn, and iterate. So it's an iterative process that we can go over and over. Let's start with research. We're going to be trying to answer different questions and at each point of our trip and of our process. Here, the important questions are who and why. So we are building security tooling. Who are we building for? That's open for everyone. Who are we building security tools for? What problems are we solving for them? And what are the existing solutions? So would you agree that we're building security tools for auditors and developers? So would you say that with this definition, we can move ahead and start building the tools? Okay, that's pretty much what everybody is doing. And we are missing like half the people we need to be thinking about. So security teams and developer teams are not just auditors and developers. We have product managers as well. We are human beings that work in technology as well. You have QAs, and you have an incredible community that want to take the opportunity of having open source projects to be able to actually check it and see the security standards they follow. So we need to think about auditors, developers, testers, product managers, and project managers, and the community overall. Why do we need to think about all of them? Because each of them have a different problem we need to solve. If we only address problems for auditors and developers, that might be a useful tool in some cases, but it's definitely not going to be a tool that helps the entire ecosystem increase the security posture. So auditors need to thoroughly audit projects. They don't care about real time. They're not coding. They're reviewing. Developers, on the other hand, need real-time updates on what they're doing, recommendations. Are they making a mistake? I cannot go backwards 2 months in advance. Like, I need to know it right away. QA requires a tool that allows them to also follow on the security posture of the team. Project managers need visibility, like otherwise we are only believing what we are told. And then users expect reliable and secure decentralized applications. So what is the state of the art? That's another question we need to answer. After we define who are we building for, what's already there? So some of the dominant techniques you're already familiar with probably: static analysis, dynamic analysis, and formal verifications, each of them with its pros and cons. Rust-based blockchains, when we started, I'm speaking 2 years ago with this research, lacked pretty much any kind of security tooling. Solidity is dominated by Mithril and Slither, but if you go ahead and read the research and the papers published doing benchmarks, there is a lot of room for opportunity in both precision and recall, and fuzzing and formal verification, and still a growing field within the Solidity community. So insights from our research. There's a lack of static analyzer for Rust-based blockchains. Auditors and developers are discontent with the output of the current solutions, and medium to high barriers of entry for everybody, not hardcore dev, to trying to get in and use them. And developer teams require intuitive solutions. And it's important for us to speak about developer teams, not just developer, and auditing teams, not just auditors. Now we're going to define, like, now we understand who we are building for, what's the current state of the art, what do we want to build. So for us, it was a static analyzer that helps avoid common vulnerabilities and deviation for best practices, and also allows auditors to focus on the current project logic and not on common vulnerabilities they should have found. The team should have even found before submitting for an audit. Let's go with build. How? How do we build it? That's the important question we need to ask. Here we need to stay about the different, and I'm sorry again, developers, for throwing all this at you, but we need to speak about the different stages of development, because it's not the same to have a proof of concept that can validate a few of the core hypotheses against a targeted subset of users, an MVP that tries to go a little bit farther, incorporate more users and functionalities, or a full-fledged product that tries to solve everything that it was the original goal. I'm going to show you a few examples of different stages of tools we have built. They're open source, they're public, you can go check them out. Some of them are for non-solidity blockchains. The last one we're going to check, it is. So Stacy was the first static analyzer for Clarity. Clarity is Stacks is a Bitcoin layer 2. Stacy is a proof of concept. It only works as a CLI tool. It doesn't go beyond. But it solves the problem for auditors, and surprisingly, even for us, has found several critical vulnerabilities during audits. Here's Stacy how it works. So we build on top of a custom three-seater grammar to build an AST and use it for our different detectors, which are then output as a CLI. Let's go with MVP. For the MVP, we tried to go a little bit further and incorporate more users. Not only auditors, but we wanted to build for developers. We are developers at our core. We built the first CLI static analyzer for Ink with a VS Code extensions for developers to have actual real-time updates. We found vulnerabilities in deployed projects and solved the problem for developers and auditors. But that wasn't the end. We wanted to take Scout to a full-fledged product and see what we could do. It became the first static analyzer for Rust-based blockchains with implementations for Ink and Sorowan today. It has a GitHub Action integration for teams to easily incorporate into the developer flow, and for open source projects, actually anybody in the ecosystem can go to the repo and check the results of running Scout. It finds vulnerabilities during audits, it provides real-time feedback to developers, and it solves the problems for everybody we create. Community is missing here, but they can actually go to open source repos and see the results. So it helps us give more trust into our projects. Scout, as you can see, is a little bit more complicated than Stacy. So we had to build, we build on top of Dilint. Luckily, when we're working on blockchain, we usually have a lot of open source tooling at our disposal, which can be a blessing when you can build on top of it. And sometimes it's a curse because it prevents you to building it from scratch, and you end up doing some compromises here and there. And spoiler alert, that's what we found when we started going into Solidity. So Scout can handle AST, but also high intermediate representation and medium intermediate representations, and allows us to give three kinds of detectors: early lean detectors, late lean detectors, and tainting-based detectors. And for the output, again, we wanted to go beyond CLI. For us, it was important that it wasn't only useful for auditors, but also for developers. So now you have real-time info in your VS Code extensions. But what happened with QA teams? What happened with developers? What happened with not technical members of the team? For them, we have Sarif complaint output. We have an HTML table where they can dynamically explore the results and the findings, and a JSON output if you want to build it and feed your own tool with it. So we spoke a little bit about research. We spoke a little bit about defining the problem, how to start building. That is, this is an iterative process. At any time, we can go to the stage before or next. And now a little bit about testing. CodeQL for Solidity. Who here is familiar with CodeQL? Have you heard about? So, great. So why CodeQL? CodeQL is a powerful code analysis tool developed by GitHub, now owned by Microsoft, of course, and enables semantic queries over large databases. And not only that, but it does it really scalable. It's really, really, really quick. Scalable and flexible, and you can customize it to detect a wide range of vulnerability and customize it for your own project. It's used globally by security researchers to uncover critical issues, and that's the people we want to get into the blockchain ecosystem. A little bit about the technical architecture. So here it's also, you can see things in common both with Stacy and with Scout. This is not a full-fledged product yet. It's a little bit more than a proof of concept, and it hasn't yet got there to an MVP. We're actually releasing it, we made it open source this morning, and we're hoping to test it with everybody here at the event to get feedback and get it to a working MVP. So it has a custom Solidity grammar that luckily we found out there. It was open source, it was already done. It has a CodeQL database extractor and generator that we had to build from scratch. Again, we took inspiration of other open source implementations of CodeQL for Web2 languages. And we started thinking about the Solidity specific components we had to build. This means the AST constructs, control flow graph, and a data flow and taint analysis. The AST constructs is pretty much done, and you're going to be able to explore it and use it. As for the control flow graph and the data flow and taint analysis, it's a work in progress. Some parts are working pretty well, some parts we're still working on and developing. We are hoping within the next month we're going to have it all figured out. So I want to try to show you a little bit of what we'll cover. For starter, how to do the environment setup. In the QR I sent you at the beginning, there is a file. All you need to do is run the file. It's going to download and install everything you need to be able to interact with our tool. I'm going to actually go ahead and show you a little bit. So, and here you're going to have to download CodeQL extension to be able to interface with it through the VS Code. Of course, it's really easy. It takes no longer than 30 seconds. And then we're going to do this. Okay. I'm going to show you how to run a detector. Sorry, I'm in Solidity. I'm here. And is it not working? Help. Thank you. Awesome, yeah. Always. So we're creating, we first created the databases. That's a really easy command. You have the file within the already installed files with the script I told you before. There you're going to go run the command, bash, db, create, blah, blah, blah. It's going to create the different databases for all current detectors. I think we have over 7 or 8 detectors working today. For starters, we want to cover all detectors already covered by Slither. And then we want to start building our own. Our process is always start researching audits. We have a really strong auditing team within CoinFabrik, but we also like to see what other persons on the ecosystem are finding and how they are reporting. Yes, of course, sorry. Better? Amazing. Facu, one of our lead researchers, everybody. Thank you, Facu. Go, Facu. Yeah, big round of applause for Facu. So it might be the other console. Are we in the wrong one? Okay. Yes, no, I was right. Sorry, it was the wrong console. So here you have the findings. Facu, no needed anymore. We have some test contracts for you to find it, but you can actually go ahead, download whichever project you want that's Solidity based, either be it your own project or any open source project you can find out there. We tried it around, against Uniswap v3 and against several open public bounties to check it out. We haven't found any vulnerabilities in production yet, but it's working perfectly fast, and it allowed us to reduce a lot of false positives we were finding. Like, it runs like really smooth, and then you can start fixing a little bit the output, and we hope, again, within the next 4 to 8 weeks, we are actually finding things in production. So we can go ahead, and it's going to highlight us where the vulnerabilities were found, and we can check it out. We can actually see the AST is not working because I'm a normie that uses Windows. Everybody here, I assume, has either Mac or Linux, so it will be working fine for you guys. You can go there, view the AST, and just start. It's going to open a folder-style view where you can go ahead and go over the AST. So let me get a second back here. So why did we build CodeQL for Solidity? Like, there's pretty much everybody here has built a Solidity contract. You probably use either Slither, Mithril, or one of them. If any of you work in security, you have probably complained a lot about the outputs, about the time you need to spend discarding false positives. For example, we did 2 months with the University of Buenos Aires researching the state of the art and benchmarking the different tools. Most of the actual open source security tooling for Solidity does not work against the current versions. Only Slither, Mithril, and a few more still works. And even those carry on errors from the beginning. Like, they're really old projects and really useful because they made a change within the ecosystem. But now, having so many people involved and being built in such a decentralized ways sometimes has its compromises. And for example, we found that for the reentrancy detector, there is actually one detector that the only thing that does is brings false positives. That the only thing you would need to do to make it better is turn it off. And there are problems with the intermediate representation here and there, which sometimes it doesn't matter really that much. But when you're trying to build a new detector, a custom detector, you start seeing things don't working. And we thought about taking the same approach Slither did, building a static analyzer from scratch as we did for Rust. But then you have a problem. The Solidity compiler is not that friendly. It's not that friendly as the Rust compiler that lets you know a lot of things, give you a lot of information that you can build on top. So we understood why Slither and Mithril had to compromise. It's not their fault. Like, it's a thing they're working. So we try to, the techniques they are using are not producing the results we are looking for, so what do we need to do? And again, it's an iterative process. Define different. So we don't need to build a static analyzer from scratch. We need to go a little bit backwards and see if the different techniques useful. Our CEO has always been in love with Semble. Semble is the tool like before CodeQL, before it was acquired by GitHub. And he threw us a challenge. Like, why aren't you guys using Semble or CodeQL? We did a research of a couple of days, and the easy reply was, there is no support. Like, there's no blockchain support, nothing we can base ourselves on. So it's pretty much starting from scratch as well. And yet again, we could starting from scratch there, we can avoid a lot of problems starting from scratch with a different technique. So we went ahead, and for the first month, we started building the database structures and generators based on different languages, and it worked. Surprisingly, it worked, and it started working. I started outputting, and we started working on the AST, and it worked. And it started working even better. And then we realized we need a CFG for the different kinds of detectors we wanted to build, and it started working. And now we are working on the data flow graph to give full functionality. Once the tool is ready, we hope it can go over entire projects, really big projects, in less than in seconds, bring valuable info, and allow teams to actually personalize, really easily build detectors for your own projects that you can later actually contribute to the core tool. Give me a second. So what are we working on now? We want to expand the library of predefined queries. Predefined queries is the equivalent of detectors here, only you are actually writing in a way that is way closer to querying a database than building a detector in Slither. We want to expand support to fully cover the Solidity language. We want to improve UX, UI. As you saw, this is not Scout, this is not beautiful, this is not useful for me. It was really hard for me to actually go ahead and prepare it for using it. We want to bring dynamic HTML here, we want to bring PDF outputs here, and we want to make it useful for the entire community, not just, again, developers and auditors. Again, no, this is wrong. I'm going to show you something else. Give me a second. I want to show the documentation. We have it on the DocuServer, sorry. Again, we finished publishing everything today to make it available open source. We were working in-house, but again, we didn't want to show a tool you guys cannot try. Love you. Here. So now I'm going to show you the documentation, because even if it's not beautiful, the output, you need to build it in a way that anybody can go ahead and understand it, and that's really important for us. So we always try to publish every tool, even if whether it's a proof of concept, a full-fledged product, or an MVP. We want everybody to understand what we try to achieve, how they can collaborate, and how to make it their own. So here you're going to have an easy tutorial on how to run the tool, an overview of what it does, an updated project status that we are working every week and updating it, how to get started, and I want to show you. Here you're going to be able to see different implementations we already have for the Solidity languages. You're going to be able to see how to contribute. We encourage everybody here to try to go ahead and make their own detectors. It's fairly easy, and you can check it against your own projects, and if it works, why not making a pull request to our GitHub and making it available for everyone. one last thing, I want to show you the different detectors we have available today. I'm going to zoom, of course. I'm so sorry. So incorrect shift, divide before multiply. This one is our canonical. This is the one we start every time we go into a new blockchain because it's the error that always can happen. We do some research. We have like a common vulnerability list that we try to check against different blockchains and languages to see if they could or not happen. Transfer from, incorrect expect, message value in for loop, unprotected self-destruct, unchecked send, is unreachable, and bad PRNG. We want to expand this against our goal for this next quarter is to reach the same amount of detectors and coverage as Leader has, but with a far better precision and recall. That's the personal challenge. This is an open source tool. We want you to benchmark it, to check it out, to give us your feedback. And now, yes, we're going to go back to the presentation. And thank you all for your time and give space for any questions. Please go ahead and try the tool. Thank you. Any questions? You can ask technical questions. The technical team is here as well. So you don't need to settle for a PM response. Here?
There is any formal verification? Hi. Is there any formal verification technique in your toolkit?
Within the toolkit, not yet. We have explored it. It's the thing with formal verification is you need a lot of user input and previous work. We try to work with teams that perhaps auditors usually are not participating in the project from the get-go. So, and if it's not fairly well documented, it's going to be hard to define different constraints and expected outputs. So not yet, but it would be actually possible to do different ways of formal verification with the implementation of CodeQL for Solidity that we're building.
Okay. Yeah, because maybe you could integrate with Halmos. Could be a good idea.
Halmos, definitely we're going to check it out. Thank you so much.
You're welcome.
Yet again, thank you everybody for your time. I hope you go ahead and try SAS Code and CodeQL for Solidity. Thank you very much.